Case study, Integrating AI for Enhanced Cybersecurity, a Transformation Journey at TechSecure Inc. Cybersecurity breaches are not a question of if, but when, especially in an era where AI and cybersecurity are becoming increasingly intertwined. In this context, TechSecure Inc., a mid-sized technology firm specializing in cloud services, found itself at a crossroads. The firm had been experiencing a series of increasingly sophisticated cyber attacks, each more damaging than the last. Realizing that traditional security measures were no longer sufficient, the executive team decided to explore AI-driven solutions to bolster their cybersecurity framework. TechSecure's IT director, Emma Collins, and her team were tasked with this critical transformation. Their first step was to integrate advanced threat detection systems that leveraged machine learning and deep learning algorithms. These systems could analyze massive data sets to identify patterns indicative of cyber threats. The question arose, how can ML and DL algorithms improve threat detection compared to traditional rule-based systems? The team implemented a solution similar to the one described by Sarkar et al., which enabled their system to detect anomalies in network traffic, such as distributed denial-of-service attacks. By continuously learning from new data, the system's detection accuracy enhanced over time. However, identifying threats was only half the battle. Predictive analytics using AI was the next frontier. By analyzing historical data, the team aimed to forecast potential vulnerabilities and attack vectors. They evaluated the capabilities of IBM's Watson for cybersecurity, which uses cognitive computing to process vast amounts of unstructured data, providing foresight into potential threats. This led to another complex question. What are the advantages of using predictive analytics to preempt cyber threats? Implementing this system allowed TechSecure to fortify weak points in their infrastructure before they were exploited. As a result, they could take proactive measures, significantly reducing the risk of breaches. The team also faced the challenge of response time, a critical factor given the speed at which cyber attacks can escalate. Traditional methods requiring human intervention were too slow. Therefore, they adopted AI-driven automated response systems capable of isolating compromised network sections, deploying patches, and rolling back to pre-attack states autonomously. Cisco's report on AI-enabled security systems suggested that these could reduce the time to detect and contain breaches by up to 27%. This brought up another crucial question for the team. How can automated response systems reduce damage during cyber incidents? The implementation of these systems drastically cut down response times, limiting the attacker's window of opportunity and minimizing potential damage. Emma's team recognized that endpoint security was another critical aspect, as endpoints like computers and IoT devices were frequent targets. They decided to use Darktrace's Enterprise Immune System, which employs AI to establish a pattern of life for every device and user within the network, detecting subtle signs of compromise in real time. This led to an insightful query. In what ways can AI enhance endpoint security to detect sophisticated attacks? This step ensured that even highly sophisticated attacks, which traditional security measures might miss, were identified and mitigated swiftly. Explainable AI was another area of focus, addressing the black box nature of AI algorithms. Understanding the rationale behind AI decisions was crucial for trust and compliance. The team implemented XAI techniques to make the AI-driven actions transparent. This posed yet another question. Why is explainable AI important in cybersecurity? By providing clear explanations of AI-driven actions, cybersecurity professionals could better understand, trust, and effectively utilize these systems. The sophistication of cyber threats also prompted the deployment of AI-driven deception technologies. These technologies created realistic decoys and honeypots to lure attackers away from valuable assets. By analyzing attackers' behavior when they interacted with these decoys, the team gained valuable insights into attack methods and objectives. This sparked another question. How can deception technologies provide additional layers of defense? These insights were used to strengthen overall security measures, making it more challenging for attackers to achieve their goals. Ethical hacking, or penetration testing, was another vital component where AI played an offensive role. The team used AI to automate vulnerability scanning and robustness testing of their systems. This proactive approach ensured continuous testing and fortification against potential threats, which raised a pertinent question: how does AI enhance ethical hacking and penetration testing? AI's efficiency in scanning for vulnerabilities made it a powerful tool for identifying weaknesses before malicious actors could exploit them. Finally, Emma and her team recognized the importance of security awareness and training. They adopted AI-driven platforms to simulate phishing attacks and provide real-time feedback and tailored learning modules for employees. This raised an essential question: how can AI personalize training programs to improve cybersecurity practices? This targeted approach helped build a more resilient human firewall, as employees were better equipped to recognize and handle potential cyber threats. Throughout this transformative journey, Emma and her team encountered several challenges. One significant concern was the potential for adversarial attacks, where attackers could manipulate AI models to misclassify malicious activities as benign. To counter this, they worked on developing robust AI models that could withstand such attacks, ensuring the integrity of their AI-based cybersecurity measures. This posed an overarching question: how can organizations safeguard AI models against adversarial attacks? By focusing on robustness, they aim to maintain the effectiveness of their AI-driven security systems. Another challenge involved ethical and privacy implications, given that AI systems require extensive data access. Ensuring that their AI-driven solutions adhered to ethical standards and regulatory requirements was paramount. The team implemented robust data governance frameworks to protect user privacy while leveraging AI for cybersecurity. This led to a broader question: what are the ethical considerations when deploying AI in cybersecurity? Adhering to ethical standards and regulatory requirements was essential to balance the benefits of AI with privacy concerns. The rapid pace of advancements in AI and cybersecurity necessitated continuous learning and adaptation. Emma emphasized the importance of staying updated with the latest developments in AI technologies and their applications in security. Collaborative efforts between academia, industry, and government were crucial for fostering innovation and addressing evolving challenges. This raised a strategic question: how can continuous education and collaboration foster innovation in AI-driven cybersecurity? By prioritizing ongoing education and collaboration, the team ensured they were always prepared to tackle new threats. In conclusion, TechSecure Inc.'s journey exemplified how integrating AI into cybersecurity could revolutionize an organization's defense mechanisms. The team successfully implemented advanced threat detection systems, predictive analytics, automated response systems, enhanced endpoint security, explainable AI, deception technologies, AI-driven ethical hacking, and personalized training programs. While they faced challenges such as adversarial attacks and ethical concerns, the potential benefits of AI in cybersecurity far outweighed the risks. By leveraging AI's capabilities, TechSecure built a more resilient and proactive security framework, ensuring the protection of their digital assets in an increasingly complex threat landscape.